Today I wanted to go over some of the effects of starvation, short-term, prolonged, and then extended periods of starvation, and then the changes that you see physiologically. And we're going to begin by talking about some of the triggers to starvation, and then look at some of those results of short-term, prolonged, and extended periods. So beginning with the triggers of starvation, wounds and illness really lead to a stress response, and that produces a hypermetabolic state. So this obviously isn't the only cause of starvation, but the body responds to a wound or to an illness by creating stress. And in that stress response, a hypermetabolic state is brought about. The body enters a hypermetabolic state, which leads to an increase in the body's need for calories and protein, and yet at the same time, due to the wounds and illness, you get a decrease in the amount of intake of calories and protein. So once again, the body responding to a wound or to an illness, this puts stress on the body. That stress response leads to a hypermetabolic state, meaning that the body sends out a signal saying we need to increase or uptake the caloric and the protein intake, and yet at the same time, due to the wounds and illness, the caloric and protein intake goes down. So the body says, I want more, less comes in. This produces at least some level of a state of starvation. Now, over the short run, if this is not corrected, the wound isn't cured, the illness isn't taken away, the protein and caloric intake isn't increased, over the short run of this state of starvation, what you get is an increase in the nitrogen in the urine, a rapid loss of muscle and weight, and a greater output of urine. So one of the short-term effects of short-term starvation is an increase, strong increase in the nitrogen in the urine, a strong increase in the output of urine, and rapid muscle and weight loss. If it's not corrected and there is a prolonged period where once again the body is still under stress, it is in this hypermetabolic state wanting an increase in calories, an increase in protein, and that is not met, then what you start getting then is, after it's been going on for a while, is the weight loss and the muscle loss actually goes down. It doesn't happen quite as rapidly in this prolonged state, and you get metabolic acidosis. You get metabolic acidosis even though the weight and muscle loss, or because of the weight and muscle loss, is not going down quite as rapidly. What you do get, though, is a sharp increase in the ammonia in the urine and a decrease in the nitrogen in the urine. As you noticed here, short-term starvation saw a sharp increase in the nitrogen in the urine. Here, the nitrogen in the urine goes down, but the ammonia in the urine goes up. And then finally, if the starvation is not dealt with and it goes into an extended period, beyond this prolonged period, it becomes premorbid, cachexia sets in, you get weight loss, the mid-arm muscle circumference decreases greatly here, there's a sharp increase in the creatinine height index and the urinary urea, and then a decrease in the serum albumin, transferrin, and lymphocytes. So you can see how things change the longer the starvation goes on. So just once again, just to recap, due to some sort of stress on the body, for example, a wound or an illness, the stress on the body, the response to that stress is to send the body into a hypermetabolic state where the body is calling for more protein, more calories. However, that need is not met. The intake goes down due to the illness or the wound. And over the short term, the nitrogen in the urine goes up, the output of urine increases, and there is rapid loss of muscle and weight. If it's not dealt with over a prolonged period, the muscle and weight loss decreases at this stage, but metabolic acidosis kicks in and the ammonia in the urine goes up while the nitrogen goes down. And then over the extended period, premorbidity sets in, cachexia, weight loss, mid-arm muscle circumference decrease, the creatinine height index goes up, as does the urinary urea, while the serum albumin, transferrin,